Two items that are really handy around the shop are a precision straight edge and feeler gauges. These work together. You put the straight edge down on something and then you try to slide feeler gauges under the straight edge at varying thicknesses for measurement purposes to identify where there might be low spots or where things are not flat. So the reason I have these tools out right now is that it's time to reattach the wings to my table saw. These are cast iron wings, and the way I verify that I've attached them correctly is that I lay the precision straight edge on the main table across and onto the wing so that I can make sure that I get the wing flat, level with respect to the main table. As a starting point, I've attached this wing using the 3 bolts below, but I haven't tightened the bolts yet, so it's sagging and in a way that's really quite visible. The gap on their end here is so large, I certainly don't need a feeler gauge to see that. Getting this flat and level with respect to the main table usually involves a fair amount of trial and error. When it goes well, you nudge things until the wing at this end is level and flat with respect to the table, and you tighten the bolts and you end up with this end also flat and level with respect to the table, and a feeler gauge will show you that all the way through you have it aligned correctly. So I'm going to go ahead and show what happens when I tighten the bolt underneath. You'll be able to see the wing rising up and the gap at this end narrowing as I tighten this bolt. In this case, I can slide a 2.5 thou feeler gauge under the straight edge right next to the table, but I can't do it on the table. So what that tells me is that I don't even have the wing high enough right here next to the table. I need to actually nudge this side of the wing up a little bit in order to get it level before I even think about whether this is right. I can now show you an example of what happens when things don't go so well. Tightening the bolts has raised this side of the wing so high that it's now bridging over and creating a gap here. Sadly, the usual fix for this kind of problem is to loosen the bolts again to create a gap large enough to insert a shim. Making the shims that we need requires a bit of trial and error, and folks tend to experiment with a number of different materials. You can get shim stock in various thicknesses and types. I've got some steel and some brass stock here. People try aluminum foil, metal tape that's used for HVAC. Sometimes people try cutting up a soda pop can. Sometimes it's possible to find these feeler gauges so cheap that it's easiest to just cut them up and make shims out of them. So as I said, this is a process of trial and error, but the basic approach is on each try, you make some shims. If you're solving the problem that I have, which is that the wing is too high, then the shims go above the bolt. If you have the other problem where you're trying to raise the wing higher when it's tightened, then you need to somehow insert the shim from below the bolt. But either way, you're going to insert these shims and then tighten everything back up. Use your mallet to nudge things into place as best you can. Use the feeler gauges to measure how good everything fits together, and then ask yourself, is it good enough, or do I need to take it all apart, get different shims, and try again? So I've currently got this right side wing attached in a way that I'm asking myself, is it good enough? And I can tell with a straight edge and feeler gauges that at this side of the wing, there's no gap. I mean, it's just very much flat and level with respect to the table. On the other hand, if I look further out on the wing, further away from the seam where the wing meets the main table, even after inserting some shims here, I still have this side of the wing too high. And by using the feeler gauges to measure the gap in the middle where the straight edge is bridging over, I can tell that this side is about 5 or 6 thou too high. And so I need to ask myself how important that is. Is it possible that this is good enough? So if we're going to talk about the notion of good enough, it would be better if we can be a bit more specific. Let's understand a little bit more about what kinds of problems are going to be caused if these extension wings are not level and flat with respect to the main table. The first observation, and it's an important one, is that the extension wing starts 10 inches away from the blade and ends 20 inches away from the blade. So if, for example, a problem is mostly out here at the far side of the extension wing, we have to be making a cut that goes 20 inches away from the blade for the wood to be involved at all. I don't want to forget to mention that even if the piece of wood you're cutting is not wide enough to reach over onto the wing, it's pretty likely that your fence still needs to slide across the seam. So you want this seam to be very smooth. You don't want the fence tripping over a ridge in either direction. The next thing we need to observe is that if the wing is not level with respect to the table, there are really two basic possibilities. It's either too low or it's too high. If the wing is too low, that means it's not supporting a piece of wood that extended over onto the wing. It's, in some sense, like the wing isn't there. It's simply the absence of support. Whether that's a problem or not depends on the weight of the piece of wood and how far it extends and how long it is and so forth. The other possibility is that the wing is too high. And in this case, what we're messing with is the possibility that the table, in effect, is no longer square to the blade at 90 degrees. This is a different problem than lack of support and probably a more important one. Fair warning, if mentioning trigonometry is going to bring up painful memories from high school, you might want to look away. But we can use it to explain the situation here. Let's pretend that this piece of wood is the surface of the table, which is not level with respect to the blade. What we want to know is this angle. This is the angle that our problem is stealing from our 90 degrees. Back in the dark ages when I took trigonometry, I was taught SOHCAHTOA as a way of remembering sine, cosine, and tangent. The tangent of this angle is equal to the opposite side over the adjacent side. So I measured this, and the height of this wedge at the edge of the wing is 8 5/16 inches. And the edge of the wing is 20 inches from the blade. So if I take 8.3125 divided by 20 and the arctangent of that, I get about 22.5 degrees, which confirms what I already knew, that this is a 22.5 degree wedge. Of course, in our situation, this height, it's 5/1000ths of an inch. But the math doesn't care. It's still a triangle, even if it's a really, really skinny one. So we can do the calculation the same way. 0.005 divided by 20, and then take the arctangent of that. And the answer is 0.01432 degrees. Now that's the angle that's being stolen from the 90 degrees we wanted. So our actual angle is 89.99 degrees. So if you're saying to yourself, my goodness, 89.99 is so close to 90, that's got to be good enough, right? Well, I'm saying that to myself too. But let's keep in mind that sometimes, depending on the nature of the cuts we're doing and how we're assembling things, sometimes errors in woodworking add up. Let's wrap this up by summarizing the most important bits. If you're trying to get things level on your table saw, usually a low spot is less of a problem than a high spot. A high spot further from the blade is less important than one close to the blade. If you have an area right next to the blade where your table is not flat and level, that could be a really big problem. Your extension wing is, on my saw, at least 10 inches away from the blade, up to 20. So that's less of a problem. And if you're talking about a 50-inch rip fence and the problem is 49 inches away, that might not be a problem at all. In the end, all that really matters is the actual performance of the saw when I'm doing real woodworking. Is my saw doing the accurate square cuts that I expect from it? But when I'm out here in the shop, I don't like surprises and I don't like mysteries. I mess up plenty of things already without having to deal with stuff I can't explain. If I'm gonna have burn marks on my cuts, I wanna know why. Understanding a bit about how all this stuff works and even the math involved helps me know what to expect from my saw. I gotta admit, I'm a little bit tempted to try one more round of shim adjustments on that right side extension wing of mine. Try and get that error down from 5 thou to maybe 3 or 4. Would that be silly? Yeah, probably. But that's why understanding all this is actually kind of important, I think. When I decide to declare that it's good enough, I wanna know, am I just frustrated and tired after the trial and error rounds? Maybe I just need a break? Or maybe I'm just ready to stop being silly.